Now, interpreting slope. In algebra, the slope is interpreted as rise over run. So if, for example, the slope is 2, we can think of it as 2 over 1 and say that you move 1 unit to the right, you'll move 2 units up. So the rise is 2, the run is 1. As you move up 2, you move to the right 1, or vice versa. Move to the right 1, up 2. In a regression context, the slope is the heart and soul of the equation because it tells you how much you can expect y to change as x increases. In general, the units for slope are the units of the y variable divided by the units of the x variable. So suppose in studying the effect of dosage level in milligrams on systolic blood pressure, a researcher finds the slope of the regression line to be negative 2.5. Now we can write this as negative 2.5 over 1 and say that the systolic blood pressure is expected to decrease by 2.5 milligrams per gram of mercury on average per 1 milligram increase of the drug dosage. Now, suppose the point estimate for slope is b1 over 1. We can interpret the slope as the expected or average change in the y value when the x value is 1 unit larger. So if that b1 is positive, then the slope is expected to increase in the y value when the x value is 1 unit larger. And if b1 is negative, then the absolute value of the slope is the expected decrease in the y value when the x value is 1 unit larger. So in that Burger King example we just looked at, we found the slope to be 0.954. More specifically, that's 0.954 grams of fat for every 1 gram of protein. So an item that has 1 additional gram of protein would have an average increase of 0.954 grams of fat. The graph you see on the right here shows the number of newspapers delivered and total pay for Leona's newspaper job. So what does the slope of this graph represent? So what we have here, you can see that I go from 0, it looks like, well, let's use this point right here. So I go up 5 and I'm going over 20. So what that tells me is the slope is 5 or $5 over 20 newspapers. So the slope would be $5 for 20 newspapers, or that comes out to be 5 divided by 20. Whoops, try that again. 5 divided by 20, or 25 cents for every 1 paper. All right. A random sample of records of sales of homes from February 15th to April 30th, 2015 from the files maintained by the Spokane Board of Realtors gives price and size in square feet of 117 homes. A regression model to predict price from size has an R-squared of 71.4%. The residual plot indicates that a linear model is appropriate. So what are the variables and units in this regression? Okay. Well, the price and the size. So in this case, size is going to be the x value because that's the one we know. And we're going to try to predict the price. So the slope, y values over x values, that's going to be the $1,000 per square foot. So it's going to be dollars over square feet. The y value was the thousands of dollars. The x value was the square feet. And do I think this is positive or negative? Well, positive would mean that as you get more and more square footage, you should get a higher price. If it was negative, then that would mean larger homes would be cheaper. Between those, the first one makes more sense. So the slope should be positive. Larger homes will tend to be more expensive.